does x correspond to? There you go. Start it off. Do all the side-to-side stuff we can do. Okay. X goes to 15. If you start off with x, be consistent. That's all. What's going to be your next one? 7 goes to what? That's it. Nothing's really changing from what we've been doing. It matches up sides to sides to sides. So you see that the ratios are the same. Okay. Only difference is today we're going to set proportions and solve them out. Cross products we go. What do we got? 9x equals 105, I heard. So here, after that, we know to divide. Does it come out nice? Not quite, does it? So after that, we know how to change it to a fraction, don't we? Math fraction, and what do we got? 35 over 3, okay? Doesn't say anything about rounding, so we leave it as a reduced fraction, okay? How about the next one now? Start off with number 2 there, just kind of jump start you there. Same deal, match them up, okay? I always start off with the variable, okay? Where that variable's at, my teachers long ago kind of started off that's just my habit, okay? Do you have to start with the x? No, just be consistent. So x, what's x correspond to? X is the vertical, corresponds to the vertical of, yep, 4. Okay, x to 4. Now what about those, that's the verticals, right? What's the horizontals going to be? I'm sorry? Oh. Oh. Okay, here's the trick one. So it's a little tricky one. We got the small triangle, right? Let's separate these. These are overlapping triangles. 4 and 5, right? I see a big triangle there, right? Big triangle. I heard an O. It's an 8, isn't it? Okay, so it's not a 3 up there, but I'm using that 3 plus 5, ain't I? So we saw the x to 4. That was a pretty obvious one. But what a lot of students will accidentally do is 3 to 5. I totally get why you want to do that. But does that 3 represent that whole leg right there? That whole horizontal? Unfortunately not. We need that whole horizontal right there. Okay? We need that whole horizontal there, which is normal. So we need that whole horizontal there for that 3 to 5, which is 8. Okay? So now x to 4, and then what to what? I'm sorry? 8 to 5, right? Okay, so 8 to 5 then. So with those overlappings, every once in a while we got to sum that up for that large one. So my suggestion is when you see it overlapping like that, separate them out. We've done that a couple times here over the last couple weeks. And then realizing it's 8 to 5. Okay. All right, to finish it off, solving the proportion is the easy one. Today it's all about setting it up. 5x equals what? 32. Now, we know it's not going to divide. It divides nicely, though. 32 divided by 5. Now, as we do these, use some common sense, all right? The last one did, last one did not divide nicely, did it? But here, I'm fine with 6.4, okay? The fraction's also fine, too, but if it's a terminating decimal, 6.4 is, go with it. Use some common sense, okay? So 6.4 is cool, or the fraction's fine, too. And here, 6.4 is more than enough for that, all right? Now, what we're doing today is going to piggyback off of this, where we want to do the same thing, but we don't have the triangles made yet. We want to make the triangles today. So let's look at that. And as we're going to look at that, let's go look on a couple pages down the road, right here, wherever this page is. 5, 509, I think it is, 509. All right. So we're going to talk about some indirect measurement, and we're going to talk about this mirror problem and where we can do some what we call indirect measurement. And what do we mean by that? So if we place the mirror, I know it sounds kind of silly, but if we were to place the mirror, so imagine a flag pole out here, and we want to calculate the height of something, we can calculate the height of a few different ways. One way we can calculate the height of a flagpole or a tall tree is to just you could climb up of it, drop down a big tape measure and measure it that route. That's one way they do that on big trees. What's the big trees out in California, out in Washington called? Okay. Our first hour, we got through that a little bit yesterday, and they didn't realize that, but those are the Sequoia Redwood National Forests. So one way you can measure those is literally climb to the top of the canopies and drop down a big old tape measure essentially and measure those out. Okay. So another way is what we're going to talk about in our next topic is using something that you've seen in the movies called a sextant. Okay. Yeah, keep going there, Dave. Okay. Sextant. All right. There we go. You've seen those devices. Probably seen them in movies on a ship. Okay. These are measuring devices that, as you stand here, and you might have seen them as you're driving down the road, construction workers. You've seen this device where the construction worker is looking through a device, and what it helps measure is what we call an angle of elevation, angles of depression, and that is used to help with our tree. So we're going to talk about another way we can measure it. So we can measure the heights of different things in a couple of different ways. Or, is what we're coming back to this problem as, we could also do a rough measurement using nothing but a mirror. How do we do that? So we can place the mirror such a way if we walk back a little bit, place the mirror a certain amount of distance from this flagpole. And then you're going to start walking back from that mirror. And I'm going to keep looking at that mirror until I find this sweet spot in that mirror to where, as I'm looking at that mirror, I finally can look in the mirror and I see the top of that flagpole. And as soon as I walk backwards enough and I find in that mirror the top of that flagpole, I stop. And once I look at that mirror and I see the top of that flagpole and I stop, those two angles where I see now the top of that flagpole, where my eyes see that angle, see the top of that flagpole, the way that visual bounces off the mirror back to my eyes, that angle is the same angle here and here. Okay, so we have congruent angles happening. And the next thing we're going to do here is we got to assume that that flagpole is perpendicular to the ground and that you are standing perpendicular to ground. Perpendicular means what? Perpendicular means what? Right angle. And what we then have here is similar triangles. What shortcut did we just create then? What shortcut of our three did we just use? Angle, similarity, right? So a mirror, it's a crude measurement tool, crude tool that allows us to know, to measure the height of the flagpole. Now, how do we do that? We can use a simple tape measure to know what this distance is, know what that distance is, those are small distances, and how tall you are. If we know those three things, well, what we can end up doing then is setting up a simple proportion, just like you did in the homework on the warm-up a minute ago. Okay, so the angle that your eyes bounce off to see that flagpole's reflection right there, that sets it all up. Okay, so let's do that. Let's look at the next page and use that indirect measurement, which is one more page there. So on that tree, as I was talking about, that's exactly what happened here. So there's a mirror that this marine here placed a certain distance away from the base of the tree. Now those measurements aren't crazy, 16 feet, that's enough for a tape measure. So they got they got a mirror situated right there. And they knew with the tape measure, hey, this is 16 feet away from the tree. She's 4 feet away from the mirror. And we know that Maureen is 5.5 feet tall. You get those three things, we get the height of the tree, rough height of the tree. So why does this whole problem work? It's because we have angle-angle similarity. Angle-angle similarity is your go-to one. Angle-angle similarity is our shortcut that runs everything with application problems. You're going to usually assume that you have perpendicular to the ground, right angles, and most of the time you got these angles happening, good angles there. Set your proportion up now. Set up the proportion. Okay, what's the proportion going to look like then? Somebody round it off here. I always start with the height, the variable, I mean. X to 5.5, height of the tree, height of the person. If I'm going with height of the tree, height of the person, then what? Ooh, not 20. Hold on there. So I'm looking at this triangle here, right?
Yeah.
But this triangle, as we see here, okay, that 16 is already represented as from here to here.
Yeah.
Okay. Now, just a minute. On the next page, I'll do one where we're going to have to do that. I think I have to do that. Maybe that same thing. I don't remember. But see how they got that marked as 16 to there?
Yeah.
That's good to go then on that one. It's not, they're not overlapping. Okay. And then I heard 16 to 4. Today's all about trying to set that proportion based off the description. Okay, cool. Do it. 4x equals 16 times 5.5, right? Calculator says 88. Divide by x, and what's the height of that tree? Now, is it going to be exactly 22 feet? Probably not. This is what we say is indirect measuring. It's a rough estimate, but it's probably not terribly far off from 22 feet, just by using a mirror and a simple tape measure and knowing what your height is. Okay. Now, buddy here, I think it's Stacy, I think his next one, is going to do the same thing. Okay. The difference I like to talk about here with the Stacy on this one is same thing. Let's put some ground here. Let's put a tree up there. See how your tree skills are, guys. I know mine are pretty amazing. Our tree skills are better than my stick people. Where's my stick people? It's definitely not the scale. Maybe it is, I don't know. I don't really care. And here's my mirror. I place my mirror right there. So Stacy's doing that same experiment here to try to figure out the height of this tree, maybe in her yard. So she's got her tape measure out. She knows what her height is. She's trying to find the height of the tree, maybe her yard, doing that same thing. So go set up your triangles there. Go set up your labels. Take a second. Can you sketch that out? Knowing all those things. Okay. So as we do that, as Stacy looks into that mirror, she sees the top of that tree. There's my triangle. Stacy's standing perpendicular to the ground. You're assuming that tree is perpendicular to the ground as well. There's my AA similarity. What else do you got? Where's that 3 going? Where's that 18 going? Where's that 60 going? Where's the variable going? You gotta know where those 4 parts are going. X is pretty obvious, right? It's the height of the tree. I'm sorry?
Was the 60 inches go to her?
She's the height, right? It's her eye height. Essentially, it's just her height, right? Yep. So it is her. Okay. Where's the 3 going? Her on the bottom, right? Is she? It says it's between her and the mirror. Here's she and the mirror. And what's the last thing going? The 18. So it's the bottom one again, isn't it? You gotta read it, label out. Sabrina.
Could you change the height though to feet?
You better, right? Because what do we have there, Sabrina? Feet and Inches. Correct. So this is why I like to do this one. This is a good SAT problem. As Sabrina pointed out, we're all about feet, but the height is in inches, right? So that's 60. Let's pause on that. Go to your science classes where you do a ton of conversions, right? So take that 60 off to the side. 60 inches make, it's a nice conversion, isn't it? 12 inches make a foot. So what's that going to become? I heard somebody say it. 5 feet, right? 60 divided by 12. Should be able to do that conversion pretty quickly. All right. So it's a nice conversion. 60 divided by 12 is, we're actually working with 5 feet here. You got to be in the same units. That is absolutely correct. Okay. Portion's easy now. But taking that information, realizing, as Sabrina pointed out, same units, that's part of the battle. Okay, make it up, mark it up. What do we got? X to 5, cool. If you did X to 5, 18 to 3. And then you're done. Well, not done, but that's the hard part. 3x equals 18 times 5, which is, yep, 90. And x is 30 feet is roughly the height of the, whatchamacallit? That tree. Yep. Okay. All right. Let's keep talking about these trees, but let's change this around. I don't have a mirror. I've got the sun's rays coming down. Okay? So what we have now going here is the sun's rays coming down. So what do we have happening on this one? As the sun's rays come down, what's happening on this one as you're reading it? Shadows. And where do shadows occur? They occur like in the middle of the air here? No, they occur on the ground. So thankfully they labeled this one out for us. But when you're labeling these out, as you said, they occur on the ground. I don't know how many students want to take the length of a shadow and label on the hypotenuse. Okay, I've never, maybe in Peter Pan the shadow occurs like on the hypotenuse, but I don't think I've seen a shadow like that. So the shadows occur, along the ground. So we got a tree, and that sun, to cast a shadow, that sun has to be behind it, right? So the shadows, sun's here, the shadows are occurring then along the ground like that. And here's my AA similarity again. Where is it happening? Right angle. But as that sun casts this rays down, creating the shadow of the tree and the shadow of the person, they're both ending at the same spot. And there's both ending at the same spot, boom, there's my angle. This is going right back to that first problem, or that second warm-up problem from today. So Grace, what you were asking about a few minutes ago, it's the same one. Don't fall asleep on me. Okay, so we have AA similarity here. Why do we have that? Because right here, as we separate these two triangles out, I got that itty bitty one. What is that? Her height, and that's 6 feet. There's that angle perpendicular and that other angle at the end. What's the big one? 15 and 6 this time. So the tree here, this is showing that this person's standing 15 feet from the tree. It's not the shadow's length. The rays come down, making that shadow extend all the way past that 15 plus 6, which is what? 21. Okay? So as that sun's rays come down, that shadow of the tree is extending out to the shadow of the of that person. And that gives me that other congruent angle right there. Okay? So as those rays come down, it's coming down at the same angle, giving me that AA similarity. Still finding the height of the tree, aren't we? But the key on this one is realizing 21. Okay? Setting up the portion now is pretty straightforward. We've seen now a couple of those. X to what? Equals what? There you go. Thank you. 21 to 6, right? Finish it off. 6x equals 21 times. Thank you. 115.5. Divide by 6. It's a nice one, isn't it? Now here we can change it back to what, fraction? We could change it back to a fraction, but does it make sense to probably do that? You know, it's nice terminating decimal. Most people talk like 19.25 feet. Most people do not talk like 77 over 4 feet. So use some common sense here. 19.25 feet. Make it a little bit nicer than I just did. Okay. Is roughly the height of that, is the height of that tree. Okay. All right. Let's do one more here today and we'll call it. We're going to do the next page. All right. On the next page, take a look at that river, that creek. Okay. Take a minute, read through what's going on with that creek problem. Caleb and somebody else, I think. All right, give me a sec there. Read about Caleb and Lauren. Read through A, B, and C, what they'd like you to do there. C is really where we're all at with this one. So we get Caleb and Lauren standing on opposite sides of the creek, right? Caleb and Lauren standing on opposite sides of the creek. And they walked away from each other. You can see. Now, based off the description up there, are they standing exactly at the edge of the riverbank? No. How far back are they standing? Yeah, they're standing a little bit back. And that's also shown in that picture right there, as you can see. So that's what that picture is showing with that little marker, with that back 5 feet, back 5 feet. So they're not quite the edge of the riverbank. They're back 5 feet from the edge, back 5 feet from the edge. Now, first question here is, like we've been talking about, how are they similar? Why are they similar? I can't set proportion yet until I've talked about why they're similar. Anybody? It's an angle. Now I see one pair of angles. I see the rights. Where's my other one coming at? Yeah, it's that bow tie picture we've seen throughout the year. Yep, vertical angles, aren't they? Vertical angles are congruent, so therefore we got ourselves our good old angle angles. Like, it's the most powerful one. You only need two things. If you get two angles, you're good. Okay, angle similarity. Now that we know that they're similar, we can set ourselves up that proportion. Now, what are we actually asked to find? We're actually asked to find what? The width of the creek, aren't we? All right. So where's the width of the creek going? Where's our variable going then? Which of these? I get two sides up there. I'm going to call this x and y. Which of those am I going to keep? The x or the y? The y is the width of the creek. That is definitely not the width of the creek. That's like the long route, isn't it? So, as Grace said, I'm going to keep that y. That's the width of the creek. Cool. Now, as we did the first hour, we had a little bit of an issue setting up our proportion here. Okay? Let's move these two triangles off to the side, just like we've been seeing here. And let's relabel these. The itty bitty triangle is not an issue. As we can see in the itty bitty triangle, 5 and 12, that's not the issue. It's this big triangle, as Grace just said, keep the 12. Okay? So what's that? Or sorry, keep the y. My bad. Keep the y. So what's that big triangle? What's that side's going to look like? So what do we have? Grace said erase that hypotenuse. We did that. What do we know for sure in that big triangle? The 50 feet, I think I heard. Okay. What's that vertical leg going to be? What's that big lake gonna be? Five. It's not 5 and 12. It's 5 and here's 5, and it's how much more? The width of the creek, right? So 5 plus, which I don't know. Right. And maybe you said I couldn't hear it, but 5 plus y. Okay, it's 5 plus what the width of the creek is. I don't know it. That's what I get to find. So that's where we had a bit of an issue first hour. 5 plus y. Now that we have it, match up the corresponding sides. So somebody start my proportion. 5 plus y, fine. What's 5 plus y corresponding to? I'm sorry? 5, yeah, it's the vertical leg to the vertical leg equals what to what? 50 to 12. Yep. So let's run back that through there. That vertical leg to vertical leg, 5 plus y to 5. And if we start off with 5 plus y, I heard, the big triangle, 50, the horizontal to the horizontal, the big horizontal to the small horizontal. So set it up. We did. Now let's cross products. 5 plus y times 12. One more time. Don't forget about the what? Distributed property there. Okay. 50 times 5 is what? 250. And then keep going here because this is where some of you made that mistake about not distributing. So 60 plus what? 12y? And then solve it out. Subtract 60, what is that, 190? Divided by 12, what's 190 divided by 12? It is not a pretty number. 190 divided by 12 is 15.83 repeating, right? And I believe it does say about rounding it to nearest 10th. So what is it to nearest 10th? 15 point what? Yep. So the width of that creek is 15.8 feet. Okay? So Ray said keep that y, which happens to represent 15.8 feet. So 15.8 feet gets me from here to here, which is the width of the riverbank, or creek. Sorry, width of the creek. Okay? So 15.8 feet is the width of that creek. Back down a little bit further. Okay? Alright, that's what I'll shut up here for you and leave it at that. Alright? Let me